Hello everyone. So this is basically continuation of the previous lecture, and here we will explore one concept. Basically, in the last lecture, I mentioned something wrong. I was mentioning like if you have two inductors that are connected in parallel, and these two inductors are having some initial current, and if you connect this two inductor across a resistance, I said like at a steady state, both the inductor will deliver the energy to to the resistance, and there will not be any energy stored or energy preservations in the inductor L1 and L2. But things are a bit different. Basically, you can analyze this particular concept from Laplace by using Laplace and all. But I will in this lecture I will try to give you the intuitions like what is basically happening in this particular circuit. Uh, Now, let's say you have this two inductor L1 and L2, and L1 has 3 Henry and L2 has 6 Henry, and L1 and L2 has some initial current I naught and I naught, I1 naught and I2 naught, this 2 ampere and 4 ampere respectively, and you are closing the this particular switch at t equal to 0. So initially I was saying like these two inductor will deliver the entire energy to this one ohm, but things are not straightforward. We will see what is happening basically. First of all, let me tell you what will be the timing constant for the circuit, because time constant is a important parameter to analyze the transient circuits and all. Okay, so these two inductor L1 and L2, if you see the equivalent inductance, so L equivalent is 3 into 6 by 9, so it is 2 Henry. So time constant of the circuit is uh, so 2 by 1, right? So 2 second is the time constant. Now the time constant of the circuit is 2 seconds. Now the entire circuit will be depending on this time constant. Like entire time circuit means the voltage currents nature will be entirely depends on the time constant of the circuit. Time constant is 2 seconds. Okay, now basically for a uh, for a transient circuits and all, so if I write the uh, current equations and voltage equations and all, for current I1 of t, it it is simply a discharging circuit. So this current equation I1 of t will simply be the initial current 2 ampere e to the power minus t by tau, right? This is the discharging circuit standard current equations, right? We will see whether it is correct or not. And for I2 of t, it is 4, and tau I can put here 2, given as t by 2. Okay. Similarly, basically the total current I naught of t is equals to 6 e to the power minus t by 2. Now, let me draw the waveforms. Now, before I draw from these two equations, tell me which one will become zero very fast. See, it has initial value 2 ampere, it has initial value of 4 ampere. So it is clear that this particular quantity will become zero much faster than this particular quantity, right? So this is the conclusion we need actually. So let's say this is the time axis, this is my I1 of t, this is the initial current, and it will very fast decay, right? So the initial current was 2 ampere, and here the initial currents and all, so I2 of t, so it has 4 ampere current, but it will take some time, right? Because 4 ampere needs more time to become zero, right? Like that it will take more time. At infinity only they both the quantity will become zero, but what will happen, this 4 ampere will take much more time, you can say, because it needs to go from 2 ampere to 0, and now it needs 4 amperes to 0. So definitely this particular uh, current I22 of t will take more time. Now there is an important observations you can see this particular quantity is becoming 0 somewhere here. Now, for better approximation, I have considered it is exactly 0 at this instant. But basically, these are the exponential quantities. So at infinity only these two, this quantity will become 0, this quantity will become 0. But for better approximation, what I am saying, this particular current will become 0, let's say this particular instant t1. Okay, and here the t1, let's say much more than the time constant. Okay, t1 is much more than the time constant. So basically, the moment you are getting zero current at I1, you are getting some non-zero current at I2. And if I draw the voltage equations, voltage, the voltage means this voltage. See, voltage across all the three elements are same. The moment you are opening the switch, let me open this particular switch, and let's say this voltage is V naught of t, right? V naught of t. And if I write the voltage equation V naught of t, which is nothing but the I naught of t into 1, so again it is 6 e to the power minus t by 2. So my voltage equations will simply like that, like this. Okay, so let's say t1, this is the nature. Now I want to draw the equivalent circuit at t equal to t1. At t equal to t1, you got some zero current. So zero current is flowing, so this is the inductor. Maybe in this direction zero current is flowing at t equal to t1. This is the inductor L2. This is the resistance. Let's say this is a V naught of t, I1, I2. And this is the I naught. At t equal to t1, you got 0 ampere current in this direction, and but you got some non-zero current in this direction. And at the same time, you have this positive voltage. Now, what will happen? Because you are getting positive voltage across this inductor current again will start build up, but in opposite direction, because you got positive polarity here, you got negative polarity here. So current will build up in this direction, and it will be exponential in nature, right? Because your voltage is itself, it is exponential in nature. If you see at t equal to t1, the voltage v of t I can write, let's say at this instant you got some voltage v naught of v naught. So you got some v naught e to the power minus t by tau. T by tau, tau is 2, and this voltage is exponential. So this current will also be exponential, because voltage and currents for inductor are derivative relationships, and derivative of an exponential quantity is again exponential. So your current, what will happen? Your current will build up in this direction. Okay. So what will happen after this instant? Your current will build up in opposite direction. So if this is my let's say this is the positive directions of current. Initially I have assumed my current is flowing in this direction. So with respect to that my current will build up, or current will exponentially rise in this direction. Okay, so it will be having some value. Now there will be an instant, there an instant will come. Maybe I can draw it with less magnitude. Let's say this is the magnitude I'm getting for I1 of t. Now, there can be one instant at that time. What can happen? Let's say this is a particular instant. Let's say at this instant, what is happening? You are getting some current I2 of t, and you are also getting some current I1 of t. And let's say the magnitude of these two quantities are same. That means, let's say at any instant, let's say this is my T2. At instant T2, the current that is flowing in this direction, it is something I naught, and at the same time current flowing through this inductor L2, it is also I naught. So inductor current I naught here, inductor current is going in this direction, so this is L1, this is L2. The current flowing through the L1 and L2 same, so what will be the current flowing through the resistance? That will be 0. Now the moment this particular situation is occurring, So voltage across resistance simply becomes zero. Zero voltage means inductor current will remain the same. Why? Because V is equals to L di by dt, and integration di is equals to V by L dt. So if you write the, let's say if you write any if the expression in the inductor current, the moment the voltage is simply becoming zero, what will happen? Inductor current will retain its value, and it will like it will be having that value only, because it will this particular circuit now behaving as a short circuit, because zero voltage means no current is flowing. So no current is simply means you can also represent it as open circuit, not short circuit. You can also represent this as an open circuit. Okay, or that is actually your choice. Now what will happen? This I naught current basically will flow through this L1 L2. Now I hope this particular explanation is clear to you. So there can be some situation, and that situation, let's say, is coming at t equal to t2. At that moment, current flowing through the L2 is simply I naught, and current flowing through the L1 is also I naught, but in downward directions. So this current basically will flow in this circuit only, and in this case, your inductor L1 and L2 will retain some energy. It will not deliver the entire energy to the resistance. So that is the thing that I was missed out in the last lecture. But I hope this explanation will help you to understand what is basically happening. But you can basically understand this mathematical portion from by using the Laplace and all. Okay. Yeah. Thank you. If you have any doubt, you can ask me in the chat box. Thank you.